Hello, this video is about push-pull amplification. That there's a common misconception that every push-pull amplifier runs in class B and every single-ended amplifier runs in class A. But that's not true. There are single-ended amps that can run in class AB1 or even in AB2. And there are push-pull amplifiers which run in class A, like this little fellow here. So now, to have an understanding of that, now I will show you what does it mean to have class A or AB1, AB2 or class B operation for a vacuum tube, and let's see how does it affect sound. Because in case your push-pull amplifier runs in class B, it is not a push-pull amplifier, it is just a push-null amplifier. So basically, only one tube is doing activity during each half cycle, and when it's running in class A, then both of the tubes participate in providing electromotive force for the output. So basically, in class A, a push-pull amplifier behaves as a man running with two legs, and in class B it behaves as a man running with one leg. So there we go. So here let's just imagine this is the voltage that's applied to the plate voltage, and let's call it 500 volts, and it's a DC voltage. So this is a positive voltage. And now here, this will be the cathode, and that's 0 volts DC. So that is our ground. And now the grid, it's sitting below that. And let's say now that it sits at minus 50 volts DC. And why is that? Because the electrons are moved from the cathode to the plate, or also called as anode, because there is this 500 volts difference. So the electrons are torn off from the cathode, which is actually shown by this symbol. If you look at schematics for indirect heated tubes, it looks like that, and if it's a direct heated tube, then it's shown like that on the schematics. And the plate or anode is shown in the schematics just like a line. That's it. So basically what happens is that there's 500 volts difference between the two, and because the cathode is heated up to a very high temperature, close to 1000 degrees Celsius, or if it's a direct heated tube, it can be much higher than that. And because the whole thing is in a vacuum, then electrons are getting pulled off from the cathode and they bombard the anode. And to control the flow of the electrons, we have the grid. And the grid, depending on what voltage we apply to the grid, it will either allow this maximum electron flow from cathode to plate, or if we start drawing the voltage lower and lower, then the current will be cut off between these two. So we will have less current going. And this is how the vacuum tube works, that we have 0 volts for the cathode, we have a specified high voltage for the anode, and the control grid sits below the cathode. It sits right down here. And when we have the music signal, that music signal will oscillate and will go up higher, and then it will go lower, higher, lower. So when we let let's say a small sine wave, then it will increase the voltage of the grid, so make it closer to 0 volts, and then it go back to the same, and then it will go lower than that. So a sine wave when we are driving a power tube with a sine wave, it will make the grid come closer to 0 volts and then go further away, more into the negative region. So now when it's going higher, it means that the current flow here will be bigger. So there will be more electron drawn there. And when it's going that way, it means that it's shutting down the electron flow, so there will be less electrons flowing there. And there's also not just the current changing, but the voltage is changing as well. So as the as the current increases, the voltage of the plate goes down. And as the current is shutting down, then the voltage of the plate will go up higher. So there is 500 volts DC on the plate, but depending on the current, this voltage will actually fluctuate. Can go much lower than that and can swing way higher than 500 volts. And so basically this is how a signal, what a signal is doing to the grid voltage, and what the grid voltage is causing as a fluctuation for the amplifier. Now, what is it that tells whether an amplifier is class A or class B or something halfway between the two, which is called an AB? And within AB we have AB1 and we have AB2. So what's the difference between all of that? So now there are limitations of how the control grid can operate, what sort of voltages can we apply to this control grid. As you see, if we are giving a bigger and bigger voltage, bigger signal to the grid, then it will get closer and closer to 0 volts. And now the highest it can get up to 0 volt, but no higher than that, if we are using a capacitor coupled design. So if we are using a capacitor to drive our power tube, then the very highest voltage on the grid can be what is the DC differential here. So in this case it would be 50 volts signal max, because then we are hitting the ground voltage and we cannot swing it higher than ground. We are stuck there. And now if we have a direct coupled connection, or we have a transformer coupling, then we can swing it higher than this voltage. Now that's one limitation there, of course, this 0 voltage. So this is one boundary that will make a difference here. Now there's another boundary, which is a line below the -50, and this is the cutoff line. Let's say if the cutoff in this case is at -100 volts DC, it means that when our signal is dropping down here, if we reach that level, then our tube is turned off. So there's no more current running. So none of the electrons can escape from the cathode and nothing is going to the plate. And now if we set up our vacuum tube so that the grid is biased at this position, then it means that when we turn on the amplifier, it's not drawing a current. So there's no quiescent current drawn from the amplifier, and that is the pure class B operation. So the tube is shut off. And when there's a signal coming, and when the signal tells the amplifier to swing more to the positive, then we can start to see the signal. If it's not DC coupled or transformer coupled, it can be up to here, and then it can swing back. And as soon as it hits 0, instead of the sine wave continuing, it will just flatten out and become like that. And when the next cycle comes, woo, then it starts going up again. So this, because of that, because it's hitting ground zero there, and it's continuing at zero level here, this is what is called the crossover distortion in a push-pull amplifier. And now what's happening here is that for the pair of the push-pull, so while this tube, one tube, is doing this, then the other tube gets the other half of the signal. So it should be going down, because it's getting the opposite phase signal on the other tube. So in this case, it cannot go down, so the other tube is in a shutdown mode. So while one tube is doing this part of the signal, the other tube is already in that crossover distortion type of situation. I mean, just here, the operation parameters just drastically change, and it's doing nothing. And these tubes keep on switching roles. So what's happening here, if we look that this is one pair of the push-pull tube, and this is the other element, the other vacuum tube, and they are connected together by the output transformer. So this is the primary winding of the output transformer. Now there is a center tap on it, and here is your 500 volts connected. So this is where it connects to the power supply. And while this tube is working on this part of the signal, that tube is cut off. So it means that the current is flowing only in this part of the primary of the transformer. So one tube is pushing the electrons, but the other is not pulling anything. It's not doing anything. So it's just push, null. And when we hit this part of the signal, then this tube is doing the pushing and the other tube is in cutoff. It's not doing anything. So basically, when you have a class B push-pull amplifier, it's technically a push null that is only using one tube doing all the work. And the tubes are swapping the duties. So one half of the duty cycle is done by one tube, and the other half of the duty cycle is done by the other tube. So now, this is the other scenario. So if we do not bias the tube to class B, but we bias it to class A, it means that there is always a quiescent current running through the tube. And when one tube is doing this part of the amplification, so it means that it's pushing the electrons up, the other tube is pulling the electrons. So now that's a true push-pull operation. So this tube is basically pushing the electrons on this half of the transformer's primary, and that one is pulling the electrons to this half. So basically this one is pushing the electrons through the plate into the primary, and this half is pulling the electrons from the center tap to the plate. And this is one half of the duty cycle, and the other half, the flow flows, and then the push-pull goes the other direction. So here, when we are above the line, then the push-pull flow goes one way, and once we go over to the negative, then the flow direction reverses. So then it is push-pull. It's true push-pull operation, and it's symmetrical, and there's current always flowing. It does not get cut off. Now, as we are increasing the level of the signal and increasing the output, and this signal is getting bigger and bigger, after a while we run into a situation that at one point we are either going to reach the zero line here or the cutoff line. So usually tubes are biased in a way that they reach the zero cutoff line before they reach the zero voltage. Now, if there's a more unusual way when you totally symmetrically bias them. So there's like an equal distance between 0 and the bias to cutoff. And when a tube is set up like that, then it's operating in pure class A operation. And so it means that the maximum that your input capacitor can give for the tube, it will reach the limits at both ends, at both extremes of the signal amplitudes, and it will work in a symmetrical fashion, and there is no tube shutdown and no compromise to the sound, except at the very end when you run out of power, basically. Now people don't do that too often because that drastically limits the output power of an amplifier. I would say not that much drastically, but you get noticeably less output power from a vacuum tube. However, that lower number gives you a much higher quality signal, much higher quality amplification, because when you are in pure class A, you always have push-pull operations. So basically, you have both tubes giving you the output power, and the entire coil, entire primary coil is engaged at all times to produce signal. And when you are cutting off one tube, then you are basically using only 1/2 of your output transformer, which is basically means you are only using half of the inductance of your output transformer, which means 1 octave poorer bass response in comparison to using the full inductance of the coil. So now, when do we get into class AB1? So we get into class AB1 where this is biased a little bit closer to the cutoff, and then when we are giving a bigger and bigger signal, we will reach the cutoff before we reach the 0 voltage. So basically, up to this point, up to the point when we reach the cutoff voltage, it's operating in class A, and if you push your amplifier beyond that, then you enter class B. And this is called the class B1 because here, if we give bigger signal than that, so the signal will be like this, like cutting off there, but instead of going lower than that, it will just plateau down here, and it's going higher, and it can go up to here, right? It's not very nice, but I cannot see too much through my screen. I'm not looking at the paper, I'm looking at the screen. So basically you have here a signal cutoff and it going up. So basically this part of the signal is what falls into the B1 range of operation, and there you are getting crossover distortion for this part of the signal. And now, if you have an amplifier that is either direct coupled or transformer coupled, then it's not limited to 0. So basically then you have the same scenario. So you are pushing the signal lower. Now you reach the cutoff. You have this crossover distortion, and then it can go and be pushed above the 0 line. And because of that, it can really add tremendous amount of output power to a vacuum tube. So, and this is called AB2. So the B2, the 2 means that the grid voltage can swing to the positive. So basically it can become more than 0 volts DC. And when the difference between like AB1 and AB2 can be like twice the output power. And the difference between basically, so AB, there's two kinds, like AB1, AB2. So the AB and AB1 is not different. AB is just a general naming, so it's not specifying whether it's 1 or 2, it's either or. If it just says AB, we don't know it's AB1 or AB2. We have to look into it more, which is happening. And in all of these cases, A, AB1, AB2, there is a signal region when the amplifier is working in class A, which means that the quieter sounds will be produced in class A, and when you want the amplifier to work very loud, then you will first hit AB1, and then if the amp is capable, then you hit AB2, right? And the other choice was class B, when one tube is always in cutoff, and just one is doing the pushing and the other is not doing any pulling. So I hope this helps a little bit to understand what is push-pull, what is class A, AB1, AB2, what is class B operation, and really what your amplifier is doing depends on what are the operating conditions that are set up for a vacuum tube. And now you would ask the questions that how can we set it up to class A or class B or class AB1, AB2. That takes like very long discussions and the topic for many videos. And of course the best apparent sound quality with the least distortion by far can be obtained by class A. So Y is just a negligible part of push-pull amplifiers running in class A, and the simple reason is that when we go deeper into class B, so we can go from deep class A to not so deep class A when we are going to AB1, which means we are taking it out from a pure class A operation and taking it out really extremely, or we are totally moving it to class B. And the further we go from A to B, the greater the distortion becomes of that amplifier, and the less natural it sounds. However, we have way more power available. So that's the gist of it, and thank you for tuning in, and I hope it helped everyone to understand it a little bit better. Please like, subscribe, have an amazing day. Bye bye.